Welcome back to our complex analysis series, and we are continuing with question 2. Still we are verifying whether a function is analytic, and in the question 2 we have this function w, which is given as x minus iy divided by x squared plus y squared. So the question is to determine whether the function analytic. Of course, like I mentioned in the first, second, and even the third series, it will not be must that these functions are analytic. You simply need to prove that it is analytic, and to do that you refer to Cauchy-Riemann equation. If the function did not satisfy Cauchy-Riemann equation, then that function is not analytic. Like we have seen in the first question A, this function 2xy plus ix squared minus y squared, we have proven and we've seen that it is not analytic function. So now let us look at the second question, and then we will find out whether this will be analytic or not. Here w, which is the function w, is given as this is in fraction form. This is x minus iy divided by x squared minus y squared. Now this will be very difficult for us to work this way, so the very first thing you to do here is do separation of variables so that it will be indeed good for us to work with. We are trying to find out what is our real part and what is our imaginary part. So this can be represented as x is equal to x squared plus y squared, and then we'll have minus I in this case because we have this negative sign in between, so it is minus y, then minus I into y. This is also x squared minus y squared, so that now we can see clearly what is our real and the imaginary part. So in this case our u is nothing but x into x squared minus y squared, and our v is nothing but y, the part that have I, it is y into x squared minus y squared. So now we want to do our differentiation in order to determine whether this function are indeed analytic or not. You should know basics in terms of differentiation, and I will refer you to my videos on differentiation. If you look at most of the videos I have done on differentiation, there is one video that I did in 2021, that is last year video. You can confirm my YouTube channel, you will find that video, and the name of that video is differentiation on quotient rule. Why am I referring to that video? I'm referring to that video because the question that we are having here is having something to do with fraction. Fraction simply means quotient, so we are going to apply quotient rule for us to be able to manipulate this differentiation. So we are going to use quotient rule. Now we want to differentiate this in respect. We want to do our partial u partial x, partial u partial x in respect to this u, which is x divided by x squared minus y squared. And if you pay attention to that video on quotient rule, we have a formula that we normally use in quotient rule. I call it low d high minus high d low divided by low squared. We call it low d high. L can represent low, d high minus high d low divided by low squared. Now this is just like a mnemonic that enables you to remember the formula. What this means is that low is what is in the denominator. Then write what is in the denominator, and now let's see what is in the denominator here. It is x squared minus y squared. X squared minus y squared. Now we want to find the derivative. D means derivative. We want to find the derivative of what is in the numerator, that is high, what is in the numerator. And in this case, what are we having in the numerator? It is x. So we want to find the derivative of x, and the derivative of x in this case is going to be 1. Now minus this with high the low. High is what we have in the numerator is simply x. So we have x there, and then we want to find the derivative of what is in the numerator. The derivative of what is in the numerator in respect to x. In respect to x, we have 2x squared minus y squared. In respect to x, we simply be it will simply be 2x. We have x 2x. Now divide this all through. We want to divide this all through by log squared. Log squared is nothing but x squared plus y squared. So we have our x squared plus y squared. X squared plus y squared. Then all this squared. Just a minute, this is a small error here. This question, this is a positive. This is supposed to be positive. Yeah, so that we are not confused with that sign. This is positive also. If this is positive, this is also going to be positive. V, this is V. V is nothing but negative y, because of this negative sign, negative y divided by x squared plus y squared. So now we go. So this is what you have when you use this formula, low d high minus high d low, divide by low squared. You will simply get x squared minus y squared. The derivative of what we have here, which is x, is simply 1. And now we want to find the derivative of what is in the denominator in respect to x. And what is in the denominator is the x squared plus y squared. So the derivative of that is nothing but 2x, and that's why we have 2x here. We have 2x here. Now divide all this through. This is x, 2x. Let's not complicate it with different colors. That is 2x. Okay, so this is what we have here. Now let's do simplification. If we simplify this, this will simply be, because this is x times 2x, this will give you 2x squared, 2x squared, and we also have x squared here. If we do simplification, we simply end up with y squared minus x squared, y squared minus x squared, and we are still having what we have in the denominator, that is x squared plus y squared, all this squared, all this squared. So this is what we have in respect to x. So now let us go ahead and differentiate to find partial u, partial y. Partial u, partial y in this case, we want to differentiate in respect to y. We are still using the same formula. This will be negative x 2x 2y. This is 2y. Divide this by x squared plus y squared, all this squared. You simply substitute using quotient rule, and now when we simplify, what we have here is negative 2xy divided by x squared plus y squared. This is what we have. Okay, so now we want to go ahead to find dv dy. let's get some space here. Okay, let's see if we can write in this side. Good. So now we want to find partial v. We want to find partial v, partial y. For partial v, partial y, we are still using our formula low d high. If we use the formula, this will be negative x squared plus y squared. We are differentiating in respect to y, partial v in respect to y, plus y into 2y into 2y. All this will be divided by, this is going to be divided by x squared plus y squared. So now if we simplify that, what we will get here is nothing but y squared minus x squared divided by x squared plus y squared. So this is what we have as dv dou v dou y. So now we are left with one, that is dou v dou x. We want to find dou v dou x. If we do the same thing we did earlier on, we will. So dou v dou x, here we simply get dou v dou x, we will get 2xy divided by x squared plus y squared, all this squared. Now having done this, we want to check and find out if indeed these have satisfied Cauchy-Riemann equation. We want to see if it have satisfied Cauchy-Riemann equation. And according to Cauchy-Riemann equation, we know that dou u dou x in this case must be equal to dou v dou y. And we also know that dou u dou y must be equal to negative dou v dou x. This is Cauchy-Riemann equation, and we want to be sure that indeed these have satisfied Cauchy-Riemann equation. So what we can see now is that dou u dou x, which is equals to dou v dou y, is equals to y squared minus x squared. This is equals to y squared minus x squared divided by x squared plus y squared, all this squared. And we also know that dou u dou y is equals to negative 2xy. It is equals to negative 2xy. That is equals to negative 2xy, like we have here, negative 2xy. Okay, if that is the case, if that is negative 2xy, if that is the case, we can conclude by saying that this dou u dou s has been satisfied, this has been satisfied, it has been satisfied, and we can see that indeed negative 2xy has also been satisfied, as it is equal to negative 2xy as we have here. So this function is indeed analytic. So W is an analytic function.